Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Counting Oddly by Timotab, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have digits in cages, do not repeat, and must sum to the value in the top left corner of the cage. So, for example, if we say had a 3 here, this would have to be a 9, because these two digits must sum to 12, which is in the top left corner of the cage. And those are the only two digits of the cage, therefore that's why this must be a 9. And that's an example of how these cages work. We also have clues in white circles indicate the total number of odd digits that border orthogonally or diagonally the two cells immediately touching the circle, not including the two cells themselves. So that would mean this is counting the number of cells that borders the two cells immediately touching the circle. So that means in these surrounding cells here, there are 4 odd digits in these cells. And for this one, in these cells, there are 4 odd digits. In these cells, there are 9 odd digits, etc., etc. So that's how these white circles work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so around these two cells must be 9 odd cells. Well, we have 10 total surrounding this. So 9 of them have to be odd and 1 is even. Well, these add up to even pairs, or even sums. And to add up to an even sum, it has to be 2 even cells or 2 odd cells. Well, since we can't have 2 odd cells surrounding this white circle, these all must be odd digits. And this has to be a 1-5 pair here, because that's the only sum that adds up to an odd sum there. What about this? Do we have anything else here? Surrounding this is 5 odd cells. And there are only 5 odd cells per box, which means this must be an even pair, because the odd cells are already accounted for surrounding these two cells, right? There's 5 odd cells here. There's only 5 odd digits in a box. So, and 5 of them are accounted for here, so it's the same here. So therefore, these are both blue, which means the remaining digits in row 2 are all odd. And since this is all odd, adding up to 9, it must be 1, 3, and 5, which means this is a 7, 9 pair. This has to be 2, 4, 6, or 8, and that adds up with 11 to add up. It's an even and odd pair. So this must be 2 with 9, 4 with 7, 6 with 5, and 8 with 3 are possibilities. Okay. Hmm. if these were both odd. The problem is we'd have 5 odds in column 6, but none of them can be a 9, because these sum to less than 9, this only sums to 9, and therefore this cannot be 2 odds here. So this must be an even here, and this is 2, 4 as a pair. That's the only even that surrounds this 9 white circle, so the rest must be odd. So these are all odd. This has to be 1, 7 or 3, 5. We're not sure which. This must have only 4 odds surrounding it. And we already have 3 there. This is guaranteed to have 1 odd and 1 even cell to add up to an odd sum, which is 13. Which means we have all the odd digits in row 7 accounted for. So the rest cannot be odd, therefore the rest must be even. So this is even, this is even. This cannot be 5 and 7. This has to be 1, 7 or 3, 5. This can't be 1 or 5, which means this can't be 3 or 7. Okay. Okay. Surrounding this white circle, we have 2 pair. Okay, so we have a guaranteed odd here. We have a guaranteed odd here. Surrounding this, we only have 1 more odd. And surrounding this, we have to have 2 odds. So we cannot have the 2. To add up to the even sum, it's either going to be 2 evens or 2 odds, which means 0 odds or 2 odds here. Either way, then this is going to have to be 0, 2. It cannot be 2 because we already have 4 odds surrounding these cells. So this must be even and even, which means these have to both be odd. So these are both odd. We have an odd and even here, an odd and even there. One of these is odd. We have 3 evens there. We have surrounding here 7 odds. So we have 1 more even cell. Okay. Which means at least one of these is odd. And since at least one of these is odd, we have 4 odds accounted for in column 9. Which means we cannot have both of these be odd to add up to an even sum, so these must both be even. So this is a 4-8 pair here. In box 9, we have to have only 1 odd surrounding this portion here. So we have a guaranteed 2 evens at least here. And this must be a 2 evens and 1 odd pair because we already have 2 evens in the box. So this must be odd here. And surrounding this is 1 odd and 2 evens, which makes this guaranteed to be even here. That eliminates evens in the rest of the box because we have 4 evens. So that leaves just odd cells in that box. Since this is odd, this must be even to add up to 13. And we have 4 evens accounted for in box 7, which eliminates evens in the rest of the box, so these are all odd. So this is an odd even pair. So this is satisfied, the 9 is satisfied, the 4 is satisfied. this 4 is satisfied. 7. One of these cells, well, you could have both of these be odd, so that's fine. Hmm. 6 odds and 4 evens here. Oh, this cannot be 2 odd digits here. Because if that's 2 odd digits, we have 6 odd digits in column 4, which is too many. So these both must be even to add up to an even sum. We have 4 surrounding this white circle. That means, oh, it's 4 odds. Ooh. So we have 2 more evens out of these 3. Okay. Oh, we have 4 evens in box 5, which eliminates evens in the rest of the box, so these are all odd. Which means this is odd, so that's all 4 odds accounted for surrounding this white circle, so this is even, even. We have 4 evens in column 6, so this can't be even, it's odd. We have 5 odds in column 4, so this must be even. 2 evens there. That means we have 1 odd here. We have 5 odds remaining surrounding this pair, which accounts for all the odds in the box. Which means this can't be odd, it's even. We have 4 evens in row 5, so this can't be even, that's odd. This is 7 odds. We already have 3 evens, so the rest must be odd. That means we have in column 9 5 odds, so this can't be odd, it's even. We have 5 odds in this right central box, so the rest must be even. We have 4 evens in row 4, so that rest must be odd. 3, 4, 5. We have 3 odds in row 3. So this cannot be 3 odds here. It must be 1 odd and 2 evens to add up to 15. So since this is 2 evens here and 2 evens here, the rest must be odd. This is guaranteed 2 evens and 1 odd, which means to add up to an odd sum, which means this must be odd, and that makes this even. We have 5 odds in column 7, so the rest must be even. We have 4 evens in this upper right-hand box, so this must be odd. That leaves this as an odd-even pair. We're not sure. We have 4 evens in row 9, so the rest must be odd, which makes both the remaining digits even. Okay, we have 4 evens in column 2, so these must be odd left. And that's all the odds in this upper left-hand box, so that leaves us even digits. Remaining digit in column 1 has to be even. Same with column 3. So that's all the coloring. Let's just double check to make sure the white circle odd clues work. We have 1, 2, 3, 4, 5 surrounding these two. Surrounding these two, we have 1, 2, 3, 4. Surrounding these two, we have 1, 2, 3, 4, 5. Surrounding these two, we have 1, 2, 3, 4, 5, 6, 7. Surrounding these two, 1, 2, 3, 4, 5, 6. Surrounding these two, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Surrounding these two, we have 1, 2, 3, 4. Surrounding these two, we have 1, 2, 3, and 4. Okay. Remaining digits of column 9. Evens have to be 2 and 6, which means the remaining evens in the box are 4 and 8. These are 6 and 8 here as a pair. To add up to 10's 2, 4, 6, 8. Here, this must be 6 or 8 here. And this can't be 6 and 8 with 7 and 9 add up to 15. That eliminates one of these is 6 or 8. This is 6 or 8. That means this can't be 6 or 8. So this must be 2 or 4. But only 4 and 9 add up to 13. That means this can't be 4 and 6. This is 2 and 8. 8 eliminates 8 here, so this is 6 and 9, adding up to 15. That means this can't be 2, 9 here, or 6, 5 here, adding up to 11. This cannot be 3 and 9, adding up to 12. It must be 5 and 7 as a pair. That just leaves 1 and 3 remaining as the odd digits in row 9. This is 1 or 3. One of these is 1 or 3 to add up to 8, so that leaves this cannot be 9, cannot be 1 or 3, so it's 5, 7. That eliminates 5, 7 in the rest of the row, so this can't be 5, 7, it's 1 or 3, which adds up with 5 or 7 to add up to 8. That leaves 9 here in this lower right-hand box. 9 eliminates 9 here, so that's 7, which makes this 9. 7 eliminates 7 here. So that's 5, which makes this 1 and 7 adding up to 8. 1 eliminates 1 here, so it's 3, which makes this 1. 1 eliminates 1 here, so this is 3 and 5. 5 eliminates 5 here, so it's 1 and 5 there. Where 3 and 5 eliminate 3 and 5 in the rest of the column, so that's 1. This can't be 1, 3, 5, or 9, so that's 7, which makes this 9 there. No one eliminates 1 here, so this must be 1 through 5. That leaves this as a 7 there. 7 in the central box cannot be here because of 7 in the column, so that leaves a 7 there. This has to then be 3, 9 as a... Well, these digits are 1, 3, and 9 as a triplet. This can't be 1 because of 1 in the row. This 1, 3, 9 triplet eliminates 1, 3, 9 in the rest of the column. So no 3 here. This is 5, which makes that 3. 7 eliminates 7 here, so it's 5 and 7. That leaves this as a 1 as the remaining odd digit. This can't be 2, 4, or 8, so it's 6. Remaining digits here are in the odd digits in row 8 are 3 and 5. This adds up to 15. Cannot be 9 or 7. This can't... The remaining digits of column 7 that are odd are 1 and 3. This can't be 1 because of 1 in the box, so that's 3, that's 1. Where is 1 in this left central box? Can't be here, so it's one of these two. That eliminates 1 in the rest of the row. So where's the 1 in the central box? It must be here. 1 cannot be here in this upper left-hand box, or here because of 1 in the rows. Can't be here because of 1 in the column. Can't be here because it adds up to 11 with a single digit. So 1 has to be there. That gives us 8 ones. We know where the last 1 has to be. It's there. 3. Where's 3 in column 9? Can't be here because 3 is in the boxes, so it must be there. Don't have any other information, really. 5s. In row 4, they have to be one of these two. So where is the 5 in column 2? Can't be here because of the way that the odds and evens worked out. Can't be here because of 5 in the row, so that means this has to be 5 because this can't be 5 and 6, adding up to 11. So 5 is here, therefore this is either 2, 4, 6, 8, adding up to 10. No 4 here means no 6 there. So this is 4 or 8, And this is 4 or 8, which eliminates 4 and 8 in the rest of the box, so this must be 2 or 6 there. So yeah. Where is 5 in row 1? Cannot be here because of 5 in the boxes, so it must be here. 7s. Where is 7 in this right central box? Cannot be here because of 7 in the column, so 7 is there. So where's 7 in row 4? Cannot be here, so this must be 7 here, so this must be a 5-7 pair, and 7 can't be here because of 7 in the column. So that's 7, which makes this a 5. 5 eliminates 5 here, so that's 3 and 5. That should be all the 5 sets. 7 should be close. We have 8 7s. We know where the last 7 has to be. It's there. 7 makes that 4. This cannot be 4 and 6, adding up to 15. Therefore, this 2-8 pair eliminates 2 and 8 in the rest of the box, so no 2 there. It's 6. 6 eliminates 6 there, so it's 2, which makes that 6. 4 eliminates 4 here, so it's 8, which makes that 4. That leaves this as a 4-6 pair, but this can't be 6 because of 6-8 pair in the column, so that's 4, which makes that 6. This can't be 8 because of the 6-8 pair in the column, so it leaves that as 2. That leaves that as 8 there. Remaining digit in row 1 is a 3. That's 3 in the corner. We celebrate because we're close to solving it. Remaining digit in column 6 is an 8. That eliminates 8 here, so it's 4 and 8. This can't be 4, 6, or 8. That leaves that as 2, which makes that a 6. That leaves that as a 2, as the only even digit, so that makes that 4. We are left with 2 and 8 remaining in column 7, and 4 and 6 remaining in column 8. And the remaining odd digit is a 9. Remaining odd digit in column 9 is a 9. That makes that 3 there, which makes that 9. Remaining odd digit in row 6 is a 3. Remaining odd digit in row 5 is a 9. Okay. Where is 4 in column 1? It has to be here. So this 4 eliminates 4 here, so it's 6 and 4. 4 eliminates 4 here, so it's 2 and 4. 2 eliminates 2 here, so it's 8 and 2. That leaves the remaining digit in row 6 as an 8. 8 eliminates 8 here, so it's 2 and 8, which eliminates 8 here, so that's 2 and 8. Which leaves this digit as a 2 and this digit as a 6. 6 eliminates 6 here, so it's 8 and 6. I don't think I would classify this as very easy. Maybe it's because I wasn't expecting this. This is a... You have to know... I feel like for this to be very easy, which it was for me, you have to have done a lot of different stuff with like the odd and even parities. And if you haven't, I feel like this isn't that easy to just see through. So I think I would classify this as just easy, not very easy here. Because it feels like it's a little more... I don't know. It just doesn't feel like it's intuitive for somebody who hasn't done very much Sudoku. And that's what I would classify for very easy, is that someone who hasn't done very much Sudoku variants should be able to pick this up and, in a reasonable amount of time, solve this. But I don't know how much... I mean, it does clue things in that you're counting the odd numbers. So maybe that makes it easier for people to think about. I don't know. I feel ambivalent about this because it feels like it doesn't feel like a very easy puzzle to me. It feels like more of an easy puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.